I'm a little surprised. I'm more than surprised. I'm a little scared, actually, because you all clearly care a lot about this topic of estimation. And I wonder why. What has this got to do with software development? I don't know. But clearly it's a part of everybody's lives, or we wouldn't see so many folks interested in the topic. It's also probably one of the painful ones. We'll get there. This is me. I am Day1Starr, work at Microsoft here. I've been doing that for a big old 3 months, 4 months or so, something like that. Had some previous lives before that, but now I'm lucky enough to work on Visual Studio. We're making some really cool stuff for you that you won't hear about this week. Yay! Okay, so we're going to talk today, obviously, about estimation, and I think a really good reason, or a really good way to start, is to admit why we do this. And this is it. We estimate because it gives us the illusion of control, and we like that. It makes us feel nice, because it reduces our fear, uncertainty, and doubt. Turns out, I was actually listening, anybody listen to NPR? The hippie station? Yeah. So I do too. And I was listening to a news report about the human brain and what causes fear. And it turns out that the root of all fear is uncertainty. Weird. Now, what does that mean to you when your manager's standing over your shoulder? And what does it mean to you when you're standing over your developer's shoulder? Your fear does not help anybody churn code out. So, the real truth is that we estimate for this reason, because we want to be able to forecast some kind of projected path. That's all fine. And we want to know either when something's done, or we want to know what will be done by a certain date. And those are actually two quite different questions. Now, before we dive too much further into this, let's think for a moment about this plan that we're trying to build with these elusive estimates. What is a plan? Well, I would venture to say it's a little bit different definition than that. And I love the fact that we're planning for software, because what we're doing is we're wrapping fake ideas around things that don't exist, that is the human work that will presumably happen, in order to create something that doesn't exist, which is software, which is really nothing but an ordered sequence of bits on some sort of storage device. Huh. I hate the fact that my entire livelihood and profession reduces to this, but nonetheless, sort of the case. Now, these are the two types of targets we might be shooting for when we try to make plans for software development and use those estimates that people ask us for. Date target, that is to say, we're going to ship on this date. We would now like to know what will be true on this date. What will our software's capabilities and behaviors be on that day? We want to make some kind of informed prediction or forecast and behave accordingly. The same could be said about feature targeting. That is to say, when will we be done with this bucket of features so that we might then release or deploy. There is a study, and trust me, there won't be a bunch of slides that have a lot of words like this, but this one does. There are a couple of gentlemen who work for Harvard Business School, and these were researchers. Back in 1998, they looked at a lot of really large-scale software development projects and came up with these three fundamental flawed assumptions about the idea of planning for a software project of any complex size. And it really comes down to these guys asserting that it's really not possible. It's really not possible to plan and be correct about what we think we're going to make. And that came from historical data and analysis, which jives really well with what we know as Humphrey's Law. And this gentleman, before you think that what we're talking about is a bunch of hand-wavy agile stuff, this gentleman was a fellow, the Software Engineering Institute at Carnegie Mellon. Very rich career. And he spent a lot of time looking at what made projects, or what characteristics did projects have that failed and that succeeded. And we all sort of know this little adage intuitively, right? The customer doesn't know what they don't want until they see it. Well, it's sort of a real thing that we can respect more than that. Now, this is fun. I have a prize for you. This is a book from one of the speakers here this week. He and I are doing a post-conference workshop on Friday. Richard Hunhausen wrote his latest book, Professional Scrum Development with Microsoft Visual Studio 2012. This book is yours if you can tell me exactly how many noodles are in these boxes. So here's how we're going to do that. I did not anticipate a full room. So instead, instead of everyone participating, how about we do this with the first 4 rows? How's that?
Dave, your estimations are off.
That's right. My estimation was sorely lacking. All right, now my wife and I, here's the deal. My wife and I, this morning, when I got up, we spent the first few minutes over coffee with credit cards, and we were, combing through a box of mac and cheese to see how many pieces of macaroni are there. And what you're going to do is you're going to predict how many pieces of macaroni were in that box. Not these boxes, but these boxes are very real. So if you want to come and investigate them, look at them, see what you think about these boxes.
Why don't I take them and we take it past them?
You certainly can. Here's what let's do. Let's pass these around, Jim, and then everybody in the first 4 rows, you have a sticky sitting on your desk, I hope. If you don't, we can get you more. Please write down your guess as to how many pieces of macaroni are in the box that my wife and I counted over coffee this morning. Okay? And Jim and Anthony, I wonder if you guys could be available on the ends and let people pass those stickies down. Okay? Now, while you're doing that, we'll go on and talk about a few more things. But I'm looking for a guess, an estimate, if you will, from everybody in the first 4 rows. All right. Everybody's probably heard this. This is an adage that we use when we talk about planning, particularly in agile environments. Dwight Eisenhower specifically was talking about kind of going into battle in a military sense, or he was talking about emergencies. People don't usually quote the rest of what came after that statement in the speech he was making that day. This is what it is. And what's interesting to me about this is that if you replace the word emergency with something software related, like my project, it still kind of works, doesn't it? All right. So, turns out this is a very difficult problem. And a lot of people have spent a lot of time thinking about how to solve this problem. There are some ways that people have looked at solving this problem. How many people use an estimation technique not shown on this slide? Raise your hand if you use something that is not on this slide. Okay? So the inverse clearly will be that all but 3 people in this room must use something on this slide. Raise your hand if you use something on this slide. Wow. Okay. So that's only half the room that didn't vote. Not bad. I'm actually kind of curious. So that we can get a qualitative assessment of what type of estimation practice you guys are using, whichever one it is, shout it out on 3. Ready? 1, 2, 3. I heard planning poker, but it might have been that guy. I heard story points too. Okay, all that stuff is relative estimation techniques, and that's great. It turns out this is the most popular technique for estimating software. I'm sure you've experienced it. This is all too real, isn't it? That's kind of how it goes. And the 2.5, that is not that is not a chance measure. That 2.5 is a very hard number. My wife learned it. I talked to her about it years ago. Honey, no matter what you tell me you're about to go do, it's going to take you 2.5 times longer than what you think it's going to be. And she would get really irritated and say, don't bring that engineering stuff in here. And then after a few years of this, she started multiplying by 2.5. The amount of time that she thought it would take to go to the grocery store, it's pretty awesome. It actually works. That's why when we look at these two questions, which seem perfectly reasonable on their face, how long will this take? How much will this cost? Because this is all we're after, right? Isn't this really all we want to know?
One more thing, a few managers like
What's that?
to make sure that you're working and not just pretending to do stuff.
Okay, so this gentleman says that one more element of this might be that we want to know that everybody is working. I think there's a support group that'll meet right after, but I don't think that's part of the estimation.
Any more? There's some very interesting answers, by the way.
That's great.
I would say 25% don't have their names on them.
That's all right.
Me.
That's all right. So let's do this, if you would. Anthony, would you stay up here with me and help for a few
Happy to
more
help.
minutes? Right on. So let's give those to Anthony. And right here we have a number line. 0, 500, 1,000, 1,500, 2,000, 2,500, 3,000. Let's see if we can place those out on that number line. And if a few fall down, that's fine, whatever. All right. Well, it turns out that the entire body of knowledge at the Project Management Institute boils down to the fact that my wife Eleanor needs to multiply everything by 2.5. Not really, of course. There's a huge, huge body of knowledge around how to manage projects, and a big part of that is how we do estimation. So given that there's that much study and all these different options that we've seen for how to estimate software, why in the world would you ask a developer?
Because you know you can.
Experience. They're the ones doing it. Create a sense of commitment. Oh, sir. Let's see where these are all great answers. Let's see how they play out. All right. One thing that we can consider is the idea that over time spent preparing estimates and doing estimate analysis, that our estimates actually get better. They get more accurate. They get more concise. I don't know, they get more detailed. And the proof of this is that we can estimate for so long that we have complete models of our software. That was the theory in the 90s, right? That we could build a working model, or rather a non-working model of our software and then hit code gen, and then UML spits out our app. Well, it turns out that kind of engineering and analysis is often appropriate. And sometimes it's not. But for us, that is, we developers making what is probably line of business software, we're looking for some healthy balance. And we have to strike a healthy balance based on the idea that it's fit for purpose, the accuracy, the amount of quality that we put in. It's great, right?
I can just watch them fall off the wall. You don't have to do anything. Just watch them fall off the wall.
It'll work better if you chain them together. I've had that experience. All right. It turns out, too, that what I'm asserting to you right now is a lie, but you took it and you ate it easily. This is what we were really talking about, and this is what you saw. It turns out that when we talk about estimates, the criticality of the estimate itself has nothing to do with the criticality of the software that we're building. Nothing whatsoever. I can build a pacemaker based on really loose estimates, no problem. It has nothing to do with the quality of the thing I'm making. I'll give you an example. I actually was responsible. This was a really bad idea, by the way, but I was made responsible for the NFLDraft.com 1 year, knowing nothing about football. What's that? People are still trying to help up here. I think that's awesome. There you go. Put them on the grate. This is a great sideshow, right? Okay. Here's the thing about the NFL draft. Pardon?
Well, there's no name on this one, so I'm not picking it up.
Okay. You guys could put them on the floor and make a bar chart.
We did this on purpose.
Oh, great. There's a scatter graph right there. Okay. So it turns out that the NFL draft goes off at a certain moment, period. And it turns out that people that write software in the domains of event-driven worlds like sports, the fact that the software is not ready does not mean that the ball is not going to kick off. So the NFL draft was coming. Now, I won't tell you the rest of the story about the fact that I was only, 3 years in industry and didn't know that much about database pooling yet, or connection pooling, but whatever. The amount of money that is at risk when the NFLDraft.com goes down pales or is really big. Sorry, it's really big. That's a lot of money, actually. It was a ridiculously high value thing. However, the criticality of it wasn't that great. Now, this dude turned out to be using a lot of software that had high criticality. Anybody know who this guy is? Felix Baumgartner, yeah. So this guy got in this little space capsule attached to a balloon, went 128,000 feet into the air, and jumped out. And I watched it happen on the internet. It was amazing. There was software interaction constantly throughout this event. Now, here's the deal. If the software that made sure that poor Felix was still alive didn't work, they probably would not have released the balloon. The criticality of that was much higher. So all we're really saying here is that with high estimate we had high criticality of the estimates with the NFL draft, but not high criticality of estimates on the jump, which is kind of counterintuitive. Here's the most common way we actually have that conversation with Joe where he multiplies everything by 2.5. Joe's either a manager or architect. You can almost bank on it. And asking Joe is probably going to get you the wrong answer for one of these reasons. Now, a lot of people will say, as long as he's off by the same amount every time, we're fine. Right? You guys about done?
Yeah.
This is amazing. Watch this. Because if you're off by the same amount every time, you can use something called a standard deviation, which we're about to do with the measurement of your estimates. Whoa, look at the timing on that. Amazing. Thanks, Jim.
Sure.
Thank you, guys. Okay, well, let's see what we got. It looks
Some
like...
creative answers here.
Are there?
Yes.
Well, that'd be fun. So, oh, David Batten. Where are you, man? This is awesome. 100% is his answer. Good one, buddy. Let's see. None of them. You took them all out of the box. But if you put them back in, I'd say 389. Good, thank you. All right. Well, I'm looking at the bar chart that we had laid out here. We've got a few high estimates. It looks like the average is going to be right around 600, between 500 and 600. We've got a big cluster between 200 and 300, right around 200 and 300 as well. It turns out this is the answer. So let's see, who got that? 1,243? Oh my gosh! This is amazing. Jasper, right there. I'll have your book for you after, sir. Very well done. That's incredible.
The second time he's been to that course.
Right on. Now what we just did is we sort of proved-ish, or, well, it's not true. Let's visit this again. You can't see this in the back, I'm sure, but there's a clustering happening here. We generated something of a bell curve, and that curve just happens to center on around 500 or so. Now it turns out that there was a the standard deviation for this measure would be approximately 700, right? Because really the answer is right in here. So if we estimate wrong the same every time, we'll be okay, because we can just account for that with that standard deviation by adding it to all future estimates. No problem. What we're taking advantage of here is something called the law of large numbers, which is very easily demonstrable with a set of dice. Now it's not really that interesting with a 6-sided die, but I wasn't going to sit and generate the graph with the D20 like I wanted to. So what we can see here is that as the number of attempts or the number of data points increases, the precision with which they approach the mean increases. So this is an information point that lets us know simply that estimates made by groups are more accurate and better than those made by a single individual. Not in this case. Oh my gosh, that was amazing. Still, I'm blown away by that. See, when you do stuff like this on stage, it's always a risk. All right. Well, since you're so good at this, let's see. How long will it take you to move this pile from the front yard to the backyard of my house? Jasper? What's that?
One go.
In one go, he says. Excellent. So if you were asked to estimate this, how would you answer?
Depends.
It depends. What does it depend on? Size, weight. What is it? Well, okay, so you guys are asking some good questions. Let me answer a few of them. This is a pile of lead cubes. Okay?
What do you have to use?
Oh, that's an excellent question, sir. What do we have to use as a tool?
Who is going to do it? Because if it's me, it's not going to be done.
Okay, so now people are naming some other variables of complexity, the people doing the work, the people's understanding of how to use the tools, etc. Well, it turns out if we have a point, a data point, we can use as reference, it's much easier for us to compare that data point to an unknown. And that is to say, we can look at this pile, we can assess sort of the size of a load in that wheelbarrow, and we can take all of that into account, do a little simple arithmetic, and hopefully we'll come up with something that approaches a reasonable estimate. It's easier to do when we have a known to compare against. We all pretty much know how much a wheelbarrow can hold. Now this works even when you can't see everything in the pile. Here's what you didn't know about those macaroni and cheese boxes, which you're free to take home, by the way. In those macaroni and cheese boxes, they are only about half full, maybe 2/3 at best. Further, there is a packet in there of additive, that is powder that you put into the mix, and then the kids stir it up and eat it, and you don't have to cook that night. Well, those are unknowns. You were able to estimate even when you couldn't see all of the thing you were estimating. Oftentimes, we have to rely on that standard deviation technique when that's true, though. All right, here's some more things that are kind of interesting. These are nonlinear growth curves. One represents the blue line, the Fibonacci sequence, which many of us, I'm sure, are familiar with. We use that often with story points as our units or other techniques in the Agile world. There's also the curve there. It's just a base 2 nonlinear growth curve. It turns out that if we can find places on a line like this to compare apples or to compare our wheelbarrow and our big pile and our bigger pile to, that's easier for us. So for example, it's probably not a difficult exercise to say that let's put the wheelbarrow at 1. Well, then maybe the little pile then comes out somewhere, don't know which screen is which. It'll come out somewhere around maybe the red 8 or the blue 5, and then way up on the curve, but maybe only the next number in the sequence or series comes that big pile. Now, taking all of that into account, we're looking for a specific type of number series that works well with our brains, and it turns out that history matters. This is how horse racing works, right? The odds in horse racing take into account a lot of variables, but primarily the history of each horse. Okay, so we know that history matters when we estimate whether or not one of these horses is going to win. It matters too when we estimate for software. And so to sum all of that up, what we're looking for is a technique that has these characteristics. We want something quick. Probably you're talking about low criticality systems. Not necessarily. I know there are a lot of really big brains in this room, and you guys work on some amazing things. But the low criticality estimates is probably true even for you. Okay? We want something that takes advantage of the wisdom of crowds, which is a great book if you've not read it, and asserts, that book, that this exercise that we did here on stage would somewhat work. The standard deviation of the packet and the half-full box kind of did make it work. All right.
You didn't have enough data points, though.
Pardon?
That law that you were referring to is the more you get data points, the more it goes to the average. We didn't have enough data points.
So the assertion is we didn't have enough data points to drive out the true bell curve of the estimates, because the more data points you have, the closer to correct, if you will get. Perhaps.
Your average was about 500. You just forgot to multiply by 2.5.
Oh, did you hear that? You guys forgot to multiply by 2.5. That was awesome. So true. That's great. Okay, so what's a technique that we can use here? Yeah, here you go. Planning poker. Most of us know what planning poker is. Looks like this. No? I think it does. If you've never seen planning poker actually done, never seen a team actually do it, let's look at that. Here's a team. And they're looking at estimating the work that it's going to take to go on the family vacation. So there's their first round of estimates. The rules are that everyone has the deck of cards that have on each card one of those numbers in that sequence, and they play a hand wherein they put out one of the cards as their estimate. You turn it over, and now we ask the people who are not converging to some mean number, why do you think, Homer, that it's an 8? Why, Bart, do you think it's a 1? We have that conversation, and then we try again. And sometimes you have problematic estimators, but oftentimes you'll be able to identify very quickly those people who are pretty good at this. All right, so we have the same conversation yet again, and we do it one more time. Anybody have this situation? Oh man, this drives me crazy, which is why this tends to be a not uncommon thing. I don't know about your guys' experience, but I got to tell you, mine includes this session right here on more than one occasion. And it's silly, right? It's completely silly. Well, I'll tell you, I actually had the privilege a couple of weeks ago of going out to Sandusky, Ohio in January, which is awesome if you're from Sandusky. Awesome. And taught a one-day workshop there. And one of the things that we did is I asked the room, I kind of took a room and divided it down the middle, and I said, we're gonna estimate some work items in a backlog. With this side of the room, please use planning poker. And we went through what planning poker is and how to use that, and they did. And then we had another side of the room, and I said, would you all please try a different technique? And we kind of laid it out. And that technique that I asked them to try was white elephant estimation, if anybody's heard of this. The way this goes is we take whatever estimation units we want and we write them on the wall. Now, a lot of people actually propose that we make the columns that go along with these numbers proportional in size. Whatever floats your boat. I don't have that much room. But we put this on the wall. Or maybe we use those units and put that on the wall. Or maybe you use whatever units you want. I have seen teams be very successful with units of estimation like Chihuahua, Great Dane, using dog breeds, using cars. Because what are we really doing here? We're comparing one body of work and its basic size against another. We can do the same thing when we look at these machines. Okay, so once we have our estimation units in place on our board, this is the set of rules. Now, the very first person to ever estimate and take advantage of this wall is going to pull an item from the backlog, look at it, walk over to the wall and say, I think it's about this big, and put it on the wall. Sit down. Next person has an option. I can either select another thing from the backlog, walk over and put it somewhere on the wall, or I can walk up to the wall, take one of the pre-existing estimates that's on the wall, and move it. What this does is it causes only those conversations to occur which are really needed. And one of the things that we talk about with planning poker is that everyone is heard. So I think there's a very significant difference between these two techniques in that if you're going to use white elephant estimation, hopefully you're a team that already trusts each other. If that's not true, there will probably be people who are ignored. It is faster. It does not have a mechanism for everyone on the team necessarily to be heard, because people will skip moving one of the items if they don't agree with it, if they know it was put there by their boss. All right, so let's look at how this plays out. Here's some here's a board on the wall, and up goes our very first product backlog item, if you will, and the next one goes somewhere on the board in relative size to it. My advice is, if you're just getting started with a technique like this, that you put 3 to 7-ish cards on this wall that represent bodies of work you and your team have already done. And this is pretty easy. If you look back at your shared history together, you'll have pieces of work that you all remember and understand, and you kind of think it through and remember the tragedy that was implementing that feature. Put it on the wall. And that makes the rest of the estimation go much better. Now, another thing that I find to be very useful about this technique is that we can keep the wall around. And we use it regularly to do what we call our backlog grooming. I'm sure you've either heard that term or will this week. Backlog grooming is the idea that we, as a team of people who are going to do the work, sit and look at the work represented in our product backlog and discuss it, estimate it, enough that we understand it to an actionable level of detail. That is not to say that we understand everything about how we're going to implement this feature or do this work. We understand it enough. What's enough? Well, it turns out generally what's enough is that you were able to get an estimate. That's usually about enough. So in these backlog grooming sessions, our goal is to estimate the product backlog items, but the real reason we're doing that is to drive understanding within the development team. Once we have begun this process, we now want to create what I'll call a rolling backlog projection. That is to say, the highest ordered items in the backlog are estimated. They're well understood. We know what they are, about how big they are. That tends to look like this. Now, I really do like the idea of maintaining a projection into my backlog of about 3 sprints worth of work. That is to say, my team, I actually work with a feature crew that's building software. They're back in the team room over in our building 41 right now. And they know to an actionable level of detail for an individual developer, that is tasks, exactly what they're doing in this sprint today. Sprint's going to be over on Friday of this week. Next Monday, hopefully they've sized enough of this work or estimated enough work in the product backlog that we can see about 2 sprints worth ahead. So we keep this rolling projection. Now, this turns out to be really important for the developers themselves because they don't get surprised. I'll say it this way. If you're using iterative incremental development, if you're using Scrum and you show up at a sprint planning meeting and your team is seeing the product backlog items that you as a product owner are presenting for the first time, I would assert to you that that's a fail. Now, I don't know what your opinion is, Ken, but that's mine. What, I'm getting a nod. Does that mean we're good? Yep. Excellent. That got blessed by Mr. Schwaber. He was my boss for a year, so that's...
No one's your boss.
Oh, come now. All right. Basic idea is that we want this. Now, the other thing that I like about the white elephant technique is it lets me do this. Particularly if we have a room in our organization where we can leave the wall up. Peter Provost in here? No? That's my boss. I have ordered a big rolling cork board so that we can have an estimation wall, and I don't have it yet, so I was just going to ask him for it. Okay. So it turns out that we can actually put multiple teams on this wall. That's a really cool thing. It's also kind of a scary thing because if what you're doing is you're trying to get the teams to have the same economy of estimation so that you can compare the teams, then you're a jerk. So don't do that. What it does do is it helps me as a member of Team B understand what's going on with my compatriots over there in Teams B and C. Not only that, but I can see their mental model of what a given piece of functionality looks like in terms of its size, and we can have that in common. It turns out to be very useful at the development team level to have that similarity and understanding. It's important, too, to remember that estimates of any kind are true for that long. That long. Because think about all the variables of complexity one has to take into account in order to provide an estimate of any kind. We must think about our team. What does our team know? In terms of the tools that we're going to use, that is, how are we going to make this thing? Also, what is it that we're going to make? Do I know anything about the NFL draft? I can tell you that I did not because I was a big nerd and I never cared about football. And I had to go learn all of the business rules of the draft, which I still don't care about. Okay, so it turns out that those complexities, which are immense, pale in comparison to the complexity of the team itself, to the composition of the team. You lose one person from a team, or you add one person to a team, and that changes your entire baseline, your entire economy in an instant. And so with all of these variables of complexity, which we know are true in software development, how long might an estimate be good for? It's a tough thing to talk about, particularly when you realize that a 5 today is very different than a 5 this same time next year. Why? Because that team has probably, let's just assume that we've fixed one variable of complexity. The team stayed together for that entire year. What has changed? Well, probably some of their tooling has changed. What else has changed? The thing they're working on. Because if they were still working on the thing from a year ago, they probably wouldn't need a team anymore. So those things all come together to prove that we have a changing economy at all times with regard to our estimation. Now, why are we doing this? Remember, let's go clear back to the beginning. We're doing this so that we can project things. We can forecast, which is an inherently difficult thing to believe in, but let's just assume that it works. And the way we do this is in an iterative incremental world, is we do this by measuring something called velocity. That is to say, how many units of estimated units, did a team get done in a given sprint? I'll leave all of the big discussions around what is done to someone else. But with this velocity measure, is it reasonable for this fluctuation that we see to occur? What we're looking at is one team's performance over the course of 9 sprints. One team's throughput, let's say. So is it okay, actually let's say it this way, is it good or bad that those data read the way they do, the fluctuations? Who says it's good? Cool. Who says it's bad? Oh, you guys are cheating. Yes, it's neither good nor bad, it's data. That's exactly right. Cheaters. But it's worth thinking about for a minute, because what might have been true in sprint 4? It may have been the winter holiday break. And I got to tell you, as someone new to Microsoft, I was stunned at what a ghost town this place turns into over the holiday break. My gosh, there was just nobody there. You could hear echoes down the halls. And it turns out that in sprint 5, you may very well have delivered a great deal of functionality with very little effort. Because whatever the thing was that we were using to do the work, a new tool, made us hyper-productive. And hyper-productive is an interesting word we'll get to in a minute. Given that we can predict the fluctuation in our velocity, what we can do is take aggregate measures of that velocity over time. This is a measure of our historical record. This is incredibly important. This is not a forecast. This is not looking ahead. This is a measurement. And I'll say this as many times as I can fit it in. When you can measure, do that. Measurements beat estimates every time. So what we have now is we have what project managers love to be armed with. We have the best case scenario, the worst case scenario, and the most likely, right? I'm sure that you get asked for these measures all the time. Well, I'm sorry, you get asked for these estimates all the time, don't you? Well, instead, how about we just have them measure this, ask me how big something is in a different relative estimation way, and then they can do the math on the back end. With that information, your product owner, like myself, I'm a product owner here at Microsoft, we are able to take these estimates and use them to analyze the backlog, the plan, the work that's in front of us in a way that allows us to forecast to our customers. And we can do it in 2 different ways. I can ask questions of this like, when will a certain feature be done? Let's say the second green product backlog item on this list. When will that be done? Looks like the best case is about 3 sprints. More than likely, it's going to be 4 or 5. We can also ask the inverse, right? What's the date target? In other words, what will be done by a certain date? And we can do that math too. All right. Now this is where it gets weird. Hopefully, everything we've talked about so far is something that you have heard about, because none of this was particularly new. And I don't know that what we're about to go into now is new, but it's different than what I've heard others in the Agile community talk about, and that is the reality of dollars and cents and time. Let's see how that plays out. My experience, requirements, backlogs are really only useful in a hierarchy. That is to say, in a hierarchical view of them. Think about Team Foundation Server for a moment. Team Foundation Server has within it all these work items. Those work items, the aggregate, the big pile of them, the millions of them that we have in Microsoft's Team Foundation Server instance, perhaps. That's the backlog. That is the backlog in one of these giant companies, giant systems. And so many different views of the backlog are applicable. We ask questions like, at what level of granularity and abstraction are you estimating? And it turns out, in my observation, this is the #1 source of miscommunication between people who want software and those who are capable of providing it. The level of abstraction at which we are having this conversation. If you ask me to build something, this is a false vocabulary up here, by the way. Strategic initiative, product, feature, story, task. Made that up. But you probably have some kind of nomenclature like this in your organization. The process templates inside Team Foundation Server usually assume some sort of nomenclature like this, or give one to you. Well, oftentimes you will be talking to me about something that is in your mind a feature. And as I have the conversation with you, I'm thinking about it in a different economy. I'm thinking about it from my team's level, and we only think about stories, story points, or something like that. What I really want us to note is that all the way from the top to the bottom of an organization, requirements tend to follow the hierarchy of the organization in a hierarchical org. They just do. And that's because each level is interested in an aggregate and roll-up of the level underneath it, typically. And what this means is that if we were to estimate at all of these different levels, a 5 is different for every level. Now, I've actually worked with an organization in which a group of executives sat around and used planning poker to estimate the relative predicted cost of strategic initiatives for the entire year. This was in a 500-ish sized person company. So they sat around and they used planning poker to drive out an estimate of how much they thought their strategic initiatives would cost. And then they needed another data point in order to actually have a reasonable plan. What was that? What do you need besides projected cost? Projected value. Now, as an executive, I'm sitting around this table. I should have some, good, deep understanding of the context of my company such that strategic initiative A, if we do that, I think it'll generate some amount of revenue for our company, whatever your bottom dollar is, whether it's dollars or, like it was at this organization where I worked, something we called mission points because we were a nonprofit. Well, it turns out that we can use relative estimation techniques like planning poker, like the white elephant board, to estimate value too, because we are product owners at that table, and we can guess or estimate Not only the cost, but the value. So if we put those two things together, it helps us a great deal have an ordering, if you will, based on return on investment. That's the idea. Okay, so we know now that every one of these columns represents not only a different abstraction layer of our requirement, but but also what I will now refer to as an economy of estimation. That is to say that strategic initiative, a 5 there, does not equal a 5 when you get down to the developer and say, how big is this? Those are different economies. And since they're different economies, one thing that we found really, really fun was to let the people who are in a given economy of estimation choose the name of the units they are estimating in, because it actually doesn't matter anymore. Because we're not estimating in dollars, we're not estimating in anything really, not time, not money. I mean, you've heard this about story points. They're unitless, right? What does that mean? Well, for us, it meant that we could name them anything. Executives estimate in gold doubloons. The directors estimated in BMWs. Since coming to Microsoft, speaking of BMWs, I thoroughly enjoy pulling up at a red light and playing BMW bingo. That is, just count how many BMWs I can see right now. My highest number is 13. It's pretty good. Okay, so the team can choose whatever its economy of estimation is. We are estimating in lives, power-ups. Managers estimate in time cards. Developers estimate in kills. Now, developers typically estimate in hours once you get down to a task level, but as we've already discussed, that hour estimate that they're putting in there is actually a relative estimate too. And therefore bears no resemblance to the actual number of hours that are probably going to be spent working on that particular task. All right, so that's interesting. Now what if we put all of those things together like this? This turns out to this starts getting even more interesting, because now I can see multiple economies of estimation on the board at the same time. So if we, again, I'm just making up some language there on the right, just making that up. But we could, for example, have these big epics, and those epics could estimate out in their economy, and we could see how features go into the next level down. And here's the thing that I have found useful at the development team level. To have whatever the level is above the team's thought. So if the team thinks in user stories, and let's say that the management structure above them thinks in features, let's say, put both of those economies on the board and ask the team to first estimate the feature, right? Because I can see this maybe 6 months out. I don't have a lot of detail about it. It's a really big piece of work. We think one day we're going to work on this feature. How big is it? And we put that on the feature row in this chart. Later on, we'll break it out to stories. Don't worry about that right now. What this allows us to do is draw a correlation between the economy of features and the economy of stories. This allows me to generate that 3-sprint rolling projection without decomposing all the way into the lowest level of decomposition, whatever that is. So it lets me push around really big blocks and have some degree of faith in their relative size. Now, here's where it gets ugly. The real truth of the matter is we understand not only the throughput of our teams, but also the current run rate or burn rate. One of the first questions I asked when I came to Microsoft is what is the per annual average cost of a Microsoft employee? I still don't know that number, by the way. But I asked that number because what I want to know is what is the average per hour cost of my team. And I want to know that because of this. We can look back at these various sprints and taking capital into account, any sort of capital that we may had to have outlaid during a particular sprint, we can calculate and measure the cost of each and every sprint. You could do this all the way down to the inclusion of benefits and floor space. However your bean counting mind needs to work, you can do this. And even though we talk so much about development teams never thinking at this level of abstraction, the real truth is that conversions to the time and money are legitimate. We just never ever ask the development team to do it because they're bad at it, because we don't know the difference between a 99 and a 100. So we don't ask them to do that. And everybody wants to know, everybody comes and asks me, my boss still wants to know when's it going to be done and how much is it going to cost. We have all of the data now to give that back with the story points or with some sort of unitless relative estimation economy, right? We can overlay this stuff on the backlog. We can see when something's going to be ready, and we can measure the cost of our team over time, get an average there, and we can say it's going to cost about this much. And then you can normalize these economies. Now Ken wants to shoot me, right? You really do. Because what this asserts is that I can tell you the per average cost of a user story. Of all of the things that I have done to try and answer those meddlesome questions of my bosses, these are the ones that hurt the least. And I'm probably still wrong. We friends again? All right. Thank you. Any questions?
I'll be right over.
Go ahead. I'll just repeat the question, ma'am.
I heard you ask the question. I didn't hear the answer. How long is the estimate good for?
How long is the estimate good for? It's good for that long. You didn't hear my finger snap.
That's what I missed.
About that snap of the finger along value of the estimation.
Yes, sir.
Since we are estimating relatively, the 5, today's 5 is nothing like tomorrow's 5, but it's still about 2.5 times more than the 2. So wouldn't you say that it's always worth the same? Because a 2 is a 2 and a 5 stays a 5?
What I would say is this. And I'm not trying to be petty or cute here. The real truth of the matter is these estimates that we're making aren't terribly valuable. And the reason for that is because this economy floats all the time. So your observation, I think, is a 2 always relative to a 5 in the same proportion? Yes, at that moment in time, assuming all variables are fixed when both estimates were made. Now, I make a 5 and a 2 estimate on one particular day. 3 months later, same team comes in the room, they're looking at the board, they estimate something at a 5. Can I expect that the dollar cost per point of that 5 is the same as the one they did 3 months ago?
No.
No. Exactly. Thank you. Yes, sir.
So when you're using the economy of scales, you got the epics, the features, and the stories, and they all have 5s. Do you have problems explaining to your management and your teams a 5 feature is different than a 5 story? And I guess the follow-up question is, do you actually use that method?
So I'll answer first. Have I actually done this in the wild? Yes, sir. No question, yes. And it works. How do I then explain to customers, that is, not customers, to the people doing the estimates, to the people who use these numbers? How do I get them to totally grok that a 5 from one team is a 5 from another? I talk about these economies of estimation. And we put wild and crazy names on those economies, like power-ups and BMWs, because then we can say crazy things to each other, like, that's 5 BMWs. And we know good and well we're not talking about lives or kills at that point. And I know it sounds silly, but we use these nomenclatures and languages to separate those economies in our minds. It helps a great deal. And I'm sure that, you know, in a more professional company you would use different terms, but the simple fact is it's language that I have found to help the most Yes, sir.
Would you say that as important as setting the numbers is the relationship? I think that at the end of the day, what we're really looking for is the relationship between them. Like when you say 5 BMWs, what does it really mean in terms of kills or stories or anything like that? Would that be the biggest value that you see instead of, you set the scale, but really what you're looking for is the ability to say, if a BMW has X stories and it will have probably X kills or something like that?
Well, I'll go back to here and see if I get this right. Can I assume that because I've calculated, or rather, that because my executive team has estimated a given body of work to be 3 gold doubloons, that automatically converts all the way down? No, actually the inverse turns out to be true. The most accurate estimates we get are ones that are driven by information starting down here and moving that direction. If you start at the strategic initiative level...
It's too broad.
Pardon?
It's too broad.
It's too broad. That's exactly right. What we're doing at that level is allowing us to compare apples to apples, strategic initiatives to strategic initiative, and that's fair.
Sure. So basically, you're really looking for relying on the roll-up. The lower the level, better to roll up. So it's easier for you to estimate up than estimate down.
The lower the level in the roll-up, the more I will trust the number.
Yeah.
Yes, sir. Yes, sir.
So your comment about estimate today isn't really worth much past that length of time, right?
Right.
If you find that after looking at hundreds of estimates of reasonably comparable things, you maybe get the idea that the value of a 5 is trending. You pay attention to things are getting easier, things are getting harder.
The thing is, things do get easier and harder,
Can you,
and that's why
can
the
you
numbers...
repeat the question, David?
Oh, sorry. Thank you very much. This is good because I'm going to try and restate what you said, and this might just be hard. Do we find that the that the ratio between 2 economies stays fixed? Is that no?
Here, I'll go give him the mic. Hold on 1 second.
Oh, remember your mic.
Hold on.
Get another one.
Okay, so I understand that if you have a 2 and a 5, and the 5 might get easier and the 2 didn't get any easier. So the ratios between those things might not always be constant. And you look at a bunch of 5s over time, and the question is, do you think that looking at 10 weeks worth of 5s and you compare the cost of each of those, do you see trending in that?
Yes.
Like compilers are getting easier, my team's getting better, or maybe it's getting harder to get capital for some reason.
Yes.
So trending over time helps you with that estimate. And if I could ask one more thing, do you use that to sort of make expectations on the trending, the way Wall Street talks about companies beating estimates? Okay, that should do it.
So I think that last part was how much do I trust it and what do I tell my boss?
Yeah, sure.
Yeah, okay. The ratio between a 2 and a 5 today is the same ratio, probably, between a 2 and a 5 a year from now. But the actual conversion is the one that has changed. And hopefully, if my team executes something today, they will be better a year from now, hopefully, which means that over that year, the value of a 5, once it's normalized out, will have increased by some amount. And that team can still be talking in terms of 5 and 3, they can still stay in the same units of estimation because of this fact, because of the fact that the conversion rate changes every day. And now, do I have to take that into account when I give projections? Well, of course, just like we give financial projections in the stock market, we have to convert those and account, and every projection we make, by the way, accounts for a presumed conversion or a presumed value of $1, right? Particularly if I'm talking about the value of a pound today versus a pound a year from now, and we know that we're going to have to go through that conversion. The odds of me being right are very, very low. So yes, it definitely informs the conversation. We're 5 minutes over already. Thank you all very much for coming. This was great.